In this lecture, we will talk about electrostatics. In electrostatics, we will discuss the main points only that are related to this level. Number 1, charged bodies. Number 2, we will divide the materials according to their electric properties to conductors and insulators. And we will talk about the electric properties of Earth. After that, we will see how to charge bodies by either one of 3 methods: charging by rubbing, charging by contact, and charging by induction. Number 4, we will introduce a new physical quantity, the amount or the quantity of charge Q. Number 5, we will talk about electric fields and we will learn how to draw some of them. Number 6, we will study the force experienced by electric charges on each other. Let's start with talking about charged bodies. Any object normally contains electrons in their atoms. Most are bonded to their atoms. Some are normally free, like those in metals, and others can become free by means of external factors. If 2 objects are rubbed together, one of them will lose electrons and the other gains electrons. The one that gains electrons becomes negatively charged, and the one that lost electrons becomes positively charged. Properties of charged bodies. A charged body attracts light objects like dust and small pieces of paper. Like charges repel, and unlike charges attract. So if 2 positive charges become close, they will repel. The same thing will happen if the 2 charges were negative. But if a positive charge becomes close to a negative charge, they will attract each other. This is what we call electrostatic attraction forces. The force between charges increases with increasing any of the charges and decreasing the distance between the charges. The second part in this lecture talks about conductors and insulators. Actually, here it means the electric conductors and electric insulators. Materials are classified to conductors and insulators according to their acceptance to the flow of electrons. Let's start with conductors. They are materials which contain free electrons that flow through them. In a conducting material, the electrons can move freely within its solid structure. Free electrons also make metals very good conductors of heat and electricity. Examples: copper, iron, lead, all metals. Graphite is considered a good conductor of electricity, even it is a non-metal, but it has free-moving electrons. And now let's talk about insulators. Materials which contain no free electrons that flow through them. Examples: glass, wood, rubber, plastic. An insulator should be dry, as moisture can destroy the insulation by conducting electric charges. These were very short notes about conductors and insulators. An important thing to discuss is the most popular discharging method: earthing. What is the mechanism of earthing and how does earthing take place? First, you must know that Earth is considered to be a large reservoir of charges. In other words, you can say that a positively charged body considers the Earth a negative body, and a negatively charged body considers the Earth a positive body. If on any place on Earth we have a negatively charged rod, remember that a negatively charged rod means that it has extra electrons than normal, and we connect this rod to the Earth using a wire or by direct contact. The extra electrons will escape to Earth, leaving the rod electrically neutral. But what will happen if the rod is positively charged? A positively charged rod means that there is a lack of electrons and the number of electrons are less than normal. So we have some positive ions with less electrons. If we connect this rod to the Earth using a wire or by direct contact, the needed electrons will rise from Earth through the wire to the rod. and make the rod neutral. After that, we must compare between earthing the conductors and earthing the insulators. If, for example, a negatively charged conductor rod is earthed, the extra electrons immediately escape to Earth because they move easily through the conducting rod. But if a negatively charged rod that is made of an insulating material is earthed, electrons will hardly escape. This is because the extra electrons are harder to move within an insulating material. The same thing applies if the rods were positively charged. Conductors lose their charge much easier than insulators because charges are free to move in conductors. The third part in this lecture is methods of charging different objects. 3 methods of charging we can talk about: charging by rubbing, charging by contact, and charging by induction. Number 1. Charging by rubbing. When a polythene rod is rubbed with a dry cloth, electrons are removed from the woolen cloth and deposited on the polythene rod. Woolen cloth becomes positively charged. Polythene rod becomes negatively charged. But when a perspex rod is rubbed with the dry cloth, electrons are removed from perspex and deposited on the woolen cloth. In this case, perspex becomes positively charged, but the woolen cloth becomes negatively charged. Number 2. Charging by contact. If we have 2 rods, one is negatively charged and the other is neutral. When a charged body touches another uncharged object, the 2 bodies will share the charge. Now the neutral rod becomes negatively charged. The third method is charging by induction. This is used to charge metal objects. The conductor is a metal cylinder and it is mounted on an insulating stand. Bring the charged rod near the conductor becomes polarized but it's still neutral. Connect the far side to the earth. This earthing will allow the negative charges to escape. Disconnect from earth. Finally, remove the charging rod. The conductor is now charged with an opposite charge to that on the rod. In this example, the negatively charged rod causes the metallic cylinder to be positively charged. You can charge the metallic cylinder a negative charge using the same method, but this will need a positively charged rod instead of the negatively charged one used. We can simply summarize the steps of charging by induction in 4 steps. Number 1. Approach the charged rod. Number 2. Connect the earthing. Number 3. Remove the earthing. Number 4. Remove the rod. Now we need to express the charge numerically. We need to change it to a measurable quantity. This is why we will introduce the new physical quantity, the amount of charge, or the quantity of charge Q. It is clear that the charge is formed due to the transfer of electrons. A rod that gains 10 electrons is negative. A rod that gains 4 electrons is also negative. But the first one has the greater charge. This means that the charge is a measurable quantity. Normally, that charge must be measured in a unit electron. But the electron is a very small unit to be used by common cases of charge measurements. So we will replace the electron as a unit with another bigger unit to be used. This unit is the coulomb. It's given this name after the name of the famous physicist Charles Augustin de Coulomb. But since the electron is a very small quantity of charge, it is replaced by a bigger unit, the coulomb. The total quantity of charge Q in coulombs of a charged body equals the number of electrons multiplied by the charge of a single electron. The charge of a single electron is constant, but this is not important to know in this level of physics, but maybe later. This mathematical rule is rarely used in exams. Like the magnetic poles, the electric charges do have an area where their effect can be observed. This is the electric field. Let us consider two plates. A positive plate facing a negative plate. The electric field is like a magnetic field. It is represented also by lines. These lines will have its direction. The electric field is defined as the region in space in which an electric charge effect appears. This appears as lines of electric field. There is an electric field produced by a charged body in the space around it. If a small positive test charge is placed in this electric field between the two plates, it will be repelled from the positive plate and attracted to the negative plate. This is why the electric field direction is out of the positive and into the negative. The field is stronger where the lines are close to each other. We also have to know how to draw different shapes of electric fields. First, a positively charged sphere. It will have an electric field as arrows going out of the sphere. The negatively charged sphere will have an electric field as arrows going into the sphere. When two spheres of opposite charges are close to each other, this will be the shape of the electric field between them. But when the two spheres are of the same charge, for example positively charged, this will be the shape of the electric field between the two spheres. This part talks about the electrostatic force between charged objects. This shows the effect of an electric field on an electric charge. If a positively charged particle, for example, moves in an electric field between two opposite charged plates, the particle will be repelled from the positive plate and attracted to the negative plate. If you carefully study its path, you will find that the particle moved in a straight line before it enters the electric field. Inside the field between the charged plates, it takes a curved path towards the negative plate and away from the positive plate. As the particle goes out of the electric field, it continues its path in a straight line.